Hello everyone. Today we will do class 10th chemistry. This is chapter number 1, chemical reactions and equations. Now, uh, if the milk is left at room temperature during summers, what will happen? An iron tawa pan nail is left exposed to humid atmosphere, what will happen? Grapes get fermented, food is cooked, food gets digested in our body, we respire, and chemical changes occur. And we can say that a chemical reaction has taken place. I'm sorry. Now, when we burn magnesium ribbon, which is about 2 centimeter long, by rubbing it with sandpaper and then using a pair of tongs, will burn using the spirit lamp. What will happen? Uh, it will burn the magnesium ribbon, and what it will give? The magnesium ribbons burn with a dazzling white flame. All right, and it changes into a white powder, and this powder is magnesium oxide. This is formed due to reaction between magnesium and in the air. All right. So magnesium oxide is formed if magnesium ribbon is burned. Now 1.2. If we take the lead nitrate solution and if we add potassium into it, potassium iodide solution, what will happen? A yellow precipitate of lead iodide will be formed. In this activity, lead iodide will be formed. And here, if we take zinc granules and add diluted hydrochloric acid or the diluted sulfuric acid, at that time hydrogen gases will be released around zinc granules, and flask is hot and endothermic reaction is taking place. All right, endothermic reaction is taking place now, and determine whether a chemical reaction has taken place or not. I'm not going to read all this. Now, chemical reaction we have already done. When magnesium ribbon is burned and oxygen, it gets turned into magnesium oxide. The reaction has been also been given, and magnesium and oxygen are reactant, and magnesium oxide is the product because magnesium and oxygen reacted to give out magnesium oxide as the product of it. All right. Now, this is how we can write the chemical reaction. We have to use the element sign before writing, and we have to use the sign of adding and giving out the arrow. Now, how we can balance the equation? By recalling the law of conservation of mass, neither be created nor can be destroyed in a chemical reaction. The total mass of elements present in the products of a chemical reaction has to be equal to the both mass of elements present in reactant. In other words, the number of atoms of each element remains the same before and after the chemical reaction. So if we add zinc and sulfuric acid, it will give zinc sulfate and hydrogen. Now the formula has also been given. Zn plus H2SO4 gives out ZnSO4 plus H2. And here we will do the left hand side and the right hand side. Zinc is 1. In the left hand side, hydrogen is 2. Sulfur is 1. Oxygen is 4. Now, if we talk about the right hand side, we have zinc 1, hydrogen 2, sulfur 1, and oxygen 4. That means it is a balanced reaction. Now, there are further examples also have been given. Another example is Fe plus H2O gives Fe3O2, FeO4 plus H2. All right, here we will look at the uh, we start the balancing by containing the maximum number of atoms. It can be reactant or the product. So here we can see that oxygen has the largest number of atom on the reaction side. So we will balance it on the left hand side. All right, and to do that we have to multiply one on the reactant. We have to multiply one in the reactant side by 4 so that left hand side and right hand side can be equal, and thereafter to balance it out we will change in the hydrogen as well. In products we have 2 hydrogen, and in reactants there are 8 hydrogen, so we'll multiply it by 4 in the product side. so that it can get balanced out completely. Now, the atom of iron in reactant and products to produce to balance 1 into 3, uh, the iron was less in the reactant side, so we multiplied it with 3 so that in both the left hand side and right hand side, number of atoms of iron can be equal. Thereafter, uh, count atoms of each elements on both side of the equation. We will count it, and hence we will get the equal number of atoms in both sides, that is on the reactant as well as the product side. Now the gaseous, liquid, aqueous and solid state of reactants are and products are represented by the notation G, L and AQ and S respectively. That means gaseous is G, liquid is L, aquarius is AQ and solid is S. All right, and work the word aquarius is written if the reactant or product is present at solution in water. All right. So sometimes the reaction conditions such as temperature, pressure, catalyst for the reaction are indicated above and or below the atom in the reaction. Like this, 340 atoms written, sunlight and chlorophyll has been written. These are the indications. All right, that what temperature, what are the pressure, what is the catalyst has been used. All right. Now we have the type of reactions. Now, in type of reactions, we have the combination reaction. And what is a combination reaction? There has been an example when calcium oxide or quicklime, CaO is quicklime, is in beaker and we slowly add water to this. What is the changes has been taking place? We will look at the calcium oxide reacts vigorously with water to produce slake lime. That means if we add quicklime plus water, we'll get slake lime. And what is quicklime? Quicklime is CaO, that is calcium oxide, and when we add water into it, so it will give out slaked lime, which is calcium hydroxide. All right. Now, in this reaction, calcium oxide and water combines to form a product. Uh, calcium oxide and water Calcium oxide and water reacts to form a single product, calcium hydroxide, which is a single product. That means when two or more reactants is formed as a form to give out one single product, it is known as the combination reaction. All right. Here, a solution of slaked lime is calcium hydroxide, is produced by the reaction. Is used whitewashing walls. Okay, that means slaked lime has been used for the whitewashing at walls. Now, calcium hydroxide reacts slowly with carbon dioxide in the air to form a layer of calcium carbonate on the water, on the walls. Sorry, that means calcium hydroxide was there. Now CO2, carbon dioxide, has been added from the air. At that time, calcium carbonate will be formed on the wall, and this calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the wall, gives out a shiny finish to the wall. And here, that is CaOH whole square. CaOH2 plus CO2 gives out CaCO3 plus H2O. Here CaOH2 is calcium hydroxide, is known as slaked lime, and CaCO3 is the calcium carbonate. All right, calcium carbonate. And what was the quicklime? It was CaO, quicklime. All right. When two or more substance elements compounds combine to form single product, it is known as combination reaction. And a large amount of heat is evolved, and this makes the reaction mixture warm. And heat release along with the formation of product is known as exothermic reaction. Now, when two reactants are added and when the products are formed, when product is formed, through with that product, if heat is evolved, all right, heat is released from, and there is formation of heat and heat is released. This is known as thermic reaction. Examples are burning of natural gases, that is CH4 plus 2O2 will give out CO2 plus H2O. Burning of natural gases is the exothermic reaction. Respiration is also an exothermic reaction. How? During digestion, food is broken down into simpler substances, and the the carbohydrates are broken down to form glucose, and the glucose combined with oxygen is the cells of our body and provides energy. All right, glucose combined with oxygen in cells of our body, and it provides energy. And specific name of this reaction is respiration. And here the glucose C6H12O6 is added with oxygen, and it gives out 6 CO2 plus 6 H2O plus energy. That means carbon dioxide has been formed, H2O has been formed, and energy has been released. All right. Now, what is decomposition reaction? When ferrous sulfate crystal is in a dry boiling tube, and we have to note the color of the ferrous sulfate crystal, which is green in color. All right, ferrous sulfate crystals are green in color, and when we'll put it in the boiling tube. At that time, we will heat the boiling tube, and at that time, that green color ferrous sulfate will be converted into white color. All right, and here it has also been written that the green color of the ferrous sulfate crystal has changed. It has the odor of burning sulfur can be seen. All right, that means here I've written from green color to white color, and later after decomposition to reddish brown color. Now ferrous sulfate FeSO4, after heat is given, it becomes Fe2O3, that is ferrous oxide. If we give out heat, from sulfate oxide is converted, and SO2 and SO3 has been made. What is that? SO2 is sulfur dioxide, and SO3 is sulfur trioxide. All right. Now it is known as decomposition reaction. In this reaction, we can observe that a single reactant breaks down to give simpler products. This is known as decomposition reaction. The ferrous sulfate crystals, that is FeSO4, 7H2O loses water while heating, and the color of crystal changes, and it then decomposes to ferric oxide Fe2O3, sulfur dioxide, and sulfur trioxide. And the ferric oxide is a solid while SO2 and SO3 are gases. Now, decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. The calcium oxide is called lime or quicklime. That means the calcium oxide is known as lime or quicklime. That is calcium oxide, CaO. It is quicklime. And decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is important decomposition used in various industries. That means when we decompose the calcium carbonate to calcium oxide and carbon dioxide on heating it, it is known as decomposition reaction, which is used in various industries. And calcium oxide is called lime or quicklime. It has many uses. One in the manufacturing of cement, when a decomposition reaction is carried out by heating, it is known as decomposition. Now, here decomposition action has been taking place, the breaking down into simpler substances, and how this decomposition is taking place if we are putting heat into that liquid. All right, sorry, not that liquid. That reaction we are providing heat, so it is known as thermal decomposition reaction. Another Lead nitrate powder in a boiling tube we have taken, and we are boiling it through the burner, and we can see that emission of nitrogen dioxide is taking place. It will be of brown fumes of nitrogen dioxide, NO2. When we are burning lead nitrate powder, we burn lead nitrate powder in the burners, and we can see brown fumes of nitrogen dioxide. Now, here the formula has been given: PbNO3 whole 2. When heated, it will give out PbO, lead oxide, plus NO2, nitrogen dioxide, and oxygen. All right. Another example, another reaction has been given. We have taken a mug. We have done two holes with, and we have placed cations and anions on it, and connected with the battery of 6 volt. Thereafter, we have also used the test tubes to cover it, and we have put water on it, and these are the graphite rod has been fitted. All right. And when we take we connect it with the battery, we see that there are hydrogen gases and oxygen gases released. All right. This is what we are taking place. And for example, we already know that cation, that is cat, is positive in Egypt. So cation is always positive, and it is a positively charged electrode which attracts the negatively charged gas. And anode is always negative. These are the charged electrodes with which attracts or stores the positively charged gases. Now, at cathode, negatively charged hydrogen gas is collected. All right, that means hydrogen gas is collected, and how hydrogen gas will be large in number, double the amount of the oxygen. Why? Because of the water. Water has the hydrogen atoms in it, and H minus ion will always get attracted towards the cathode, as cathode is a positively charged electrode. All right, and the oxygen will be added on the anode side, as anode is a negatively charged electrode and oxygen is a plus sign, plus group. All right. So this is what happened. We'll see that the more hydrogen is created at the cathode side, while less oxygen has been created on the anode side. Now, silver chloride is in a china dish, and we have shown the sunlight. What happens? We will see that the white silver chloride turns into gray in sunlight due to the decomposition of silver chloride into silver and chlorine by light. All right, silver chloride turns into silver and chloride by light. Now, the silver bromide also behave in the same way. We have AgBr, silver bromide. When given sunlight, we get Ag and Br. So decomposition has been taking place, and the above reaction, that is the silver bromide one, is used in the black and white photography. All right. And decomposition reaction requires energy either in the form of heat, light, or electricity. So in decomposition reaction, either we can provide heat by the burner, light by the sunlight, and electricity by the battery to break down the reactant to form heat in the form of reaction in which energy is absorbed, and are known as endothermic reaction. All right. Another is given 2 gram barium hydroxide. If we add ammonium chloride into it, all right, in barium hydroxide we have added ammonium chloride, and touch the bottom of the test tube with the palm. What do you feel? Is it exothermic or endothermic reaction? All right. Now the ammonium chloride, when reacted with barium hydroxide, it forms ammonia. All right. And the reaction between the barium hydroxide and ammonium chloride is a double displacement reaction. That means displacement reaction has been taking place, and the product of this reaction are barium chloride. That is from barium hydroxide to barium chloride, and ammonia is formed along with H2O, and this reaction is an endothermic reaction. All right. Now, what is displacement reaction? Here, if we put two nails into by rubbing it to sandpaper into copper sulfate solution in a test tube, we put it for 20 minutes, and if we take out the iron nails, we will see that the uh, we can compare the intensity of blue color of copper sulfate solution in the test tube. All right, and here iron nail becomes brownish in color. All right, that is Fe plus CuSO4, that is copper sulfate. It will give out the ferrous sulfate plus copper. Ferrous sulfate plus copper. Now, iron has displaced or removed another element. Now, iron has displaced or removed another element, copper, from copper sulfate solution, and this reaction is known as displacement reaction. All right, iron has displaced or removed another element. That is, the iron has displaced the copper, and this displacement of elements is known as the displacement reaction. Now, if we instead of iron, we if we put zinc or lead in the solutions of copper sulfate and copper chloride respectively, at that time same displacement will be taking place. Now, zinc and lead are more reactive than copper. All right, so they displace copper from its compound. The elements which are reactive in nature will displace the compound, will displace the compound of it. Now, the sodium sulfate, if we take sodium sulfate and we have barium chloride solution. All right. Firstly, we use the barium hydroxide, and we mix it with the with ammonium chloride. All right, barium hydroxide and ammonium chloride. And this time, what we are doing, we are using the sodium sulfate and barium chloride solution. We are mixing it well. What we will observe, that a white substance is formed. That is, insoluble salt is formed in water, and this insoluble substance is formed is known as the precipitate. And the reaction that produces a precipitate can be called as a precipitation reaction. That is, when we have mixed barium chloride along with the copper sulfate solution, sorry, sodium sulfate. All right, sodium sulfate and barium chloride. So Na and Cl will be added, so a salt will be formed, and sulfate and barium will be displaced. So, but a precipitation will be formed, and the solution will be substance will be insoluble in water. So this is known as the precipitation reaction. That is, Na2SO4 plus BaCl2 gives out BaSO4, Na2Cl. That means sodium sulfate added with barium chloride gives out barium sulfate and barium chloride. Now, white precipitate of barium sulfate is formed by reaction of SO4, that is sulfur tetra oxide, and the barium 2 plus, and this other product formed is barium chloride, which remains in the solution. Sodium chloride will be remaining in the solution, and such reaction, there is an exchange of ions between the reaction, is known as double displacement reaction. So, the exchange of ions will be taking place. Na plus and Cl minus will be added. Na plus and Cl minus will be added. So it will make a double displacement reaction. All right. Now, here another activity has been given. If we mix solution of lead nitrate and potassium iodide. All right. Nitrate and lead PbNO2. All right. If we have taken the lead nitrate and potassium iodide, And if you mix well and if we burn it, what is the precipitate of color? Is it a double displacement reaction? And the surface, the answer has been given that the surface of copper powder becomes coated with black copper oxide. That means the copper will be coated with the black color, copper oxide, and this is because of oxygen is added to copper to form copper oxide. All right, all right. So this is all about the oxidation reaction. So if oxygen is added into it, in oxygen is added in something, it is known as oxidation, and if hydrogen is added in something, it is known as reduction. Let's study in deep. If we add Cu plus O2, it will give out CuO. All right, oxygen is added. If hydrogen gas is passed over a heated material, CaO, the black coating on the surface turns brown as the reverse action takes place and copper is obtained. That means if hydrogen gas is passed over a heated material, CuO, the black coating of surface turns brown as the reverse reaction takes place and copper is obtained. All right, copper is obtained. So, if we pass hydrogen gas over a heated material like CuO, the black coating on the surface turns brown, and it is a reverse reaction taking place, and the substance gain oxygen known as the reaction. During reaction, if a substance gain oxygen during a reaction, it is known as oxidized. That means and the substance has been oxidized, and the substance loses oxygen during a reaction, it is said to be reduced. All right. Now the copper 2 oxide is losing oxygen and is being reduced. Now the hydrogen is gaining oxygen and is being oxidized in other ways. A reactant gets oxidized while the other gets reduced during a reaction, and such reaction is known as oxidation reduction reaction or the redox reaction. That means simultaneously oxidation and reaction has been taking place. This is known as redox reaction or the oxidation reduction reaction. Some examples of the redox reaction are ZnO plus C gives out Zn plus Co. Here ZnO has been reduced to Zn and C has been oxidized to get Co, carbon monoxide. Now MnO4 plus 4HCl, that is magnesium manganese oxide. When added with HCl, it gives manganese chloride plus H2O plus Cl. All right, the carbon is oxidized to Co and ZnO is reduced to Zn, and HCl is oxidized to Cl2, whereas MnO2 is reduced to MnCl2. And if a substance is gaining oxygen or losing hydrogen during a reaction, it is oxidized. If a substance loses oxygen or gain hydrogen during a reaction, it is reduced. That means gaining of oxygen and reducing of hydrogen means oxidation, and gaining of hydrogen and reducing of oxygen is known as reduction. All right, and here we can see when magnesium ribbon is burned, uh, and it gives out white flames and magnesium oxide is formed. Now this is a what it is a oxidation reaction because magnesium is added with oxygen to give out magnesium oxide in a substance. Now effect of oxidation or everyday life. Now we have corrosion. Iron articles are shiny when new, but they become reddish brown when they are left for some time. Rusting of iron is another example. When a metal is attacked by substance such as moisture, acid, etc., it's said to be corrode, and this process is known as corrosion. And the black coating of silver and the green coating on the copper are other examples of the corrosion. And the corrosion causes damage to car bodies, bridges, iron railings, ships, and all other objects made up of metal, specifically those of iron. Then we have rancidity. In rancidity, ever tasted or smelled the fat or oil containing food materials? Fats and oils are oxidized. They become rennet and their smell and the taste changes, and substance which prevents oxidation are the antioxidants and are added to food containing fats and oil. And keeping food in airtight container helps to slow down the oxidation. And due to that, chip manufacturers use flush packs and chips with gas such as nitrogen to prevent the chips getting oxidized. So here we have completed almost the chapter. Now let's get revision. Decomposition reaction is an opposite of combination reaction. In combination reaction, two reactants are formed together to give out a single product is known as the combination reaction. Now decomposition reaction, when one singular product is being decomposed to give simpler products, are known as the decomposition reaction. And a single substance decomposes to give out two or more substances, and the reaction in which heat is given out along with the product is known as exothermic reaction, and the reaction in which energy is absorbed are known as the endothermic reaction. That means the energy is absorbed is known as endothermic reaction, the energy is given out is known as exothermic reaction. Now, when an element displaces another element from its compound, a displacement reaction occurs. That means when an element displaces another element from its compound is known as displacement reaction. Now, what is double displacement reaction? The two different atoms or groups of atoms or ions are exchanged is a double displacement reaction. The precipitation reaction produces insoluble salt like NaCl, all right, and the oxidation is the gain of oxygen and loss of hydrogen, while reduction is the loss of oxygen and gain of hydrogen. All right, so here we have completed our chapter of 10th class as well, and I will make you study the second chapter as well, and we will complete it uh, till our whole chemistry is first covered. Thereafter, we will go to the biology, and thereafter to the physics. So, in this way, we will study the complete ninth and 10th NCRTs based on organizing skills. All right, everything will be organized, and it will be helpful for the further examination or personal health, personal benefits. Sorry, not health benefits. So, thank you everyone for studying. Jai Hind.